Okay, when we're adding integers with different signs, things are a little bit trickier than when we're adding integers with the same signs. Our song is same signs add and keep, but these aren't the same signs, so that's not going to work. Different signs subtract. So we're going to subtract these numbers first and then keep the sign of the bigger number, then you'll be exact. So let's talk about this. Same signs add and keep. Nope. Different signs subtract. So we're going to subtract these numbers. I'm always going to use the larger number first because I'm going to attach a sign to this number at the end once I find the difference. So 12 minus 4 is 8. And then I'm going to keep the sign of the larger number. When I say larger number, I mean the absolute value of that digit. So the absolute value of negative 12 is 12. The absolute value of 4 is 4. So really, this guy right here, he's the bigger guy. He wins. There are more negatives than there are positives. So he's like, I'll win. The answer's going to be negative. So when I look up and see which one's bigger, the 12 is bigger. There are more negatives. So my answer is not going to be 8. It's going to be negative 8. Because when I take away those pairs, I'm going to have negatives left over. So let's do it again. Same signs add and keep. Different signs subtract. I'm going to start with my 8 first. 8 minus 4. 8 minus 4 is 4. Same signs add and keep. Different signs can subtract. Keep the sign of the bigger number. I win the battle. The answer is negative because negative 8 is bigger than 4. Bigger, quotation marks. It's not really bigger in value, but the absolute value is bigger. There are more negatives here than there are positives, so our answer is going to be negative 4. Here's another one. Same signs add and keep. Different signs subtract. So I've got 10 minus 3, which is 7. Keep the sign of the bigger number. Aha, this 10 is the bigger one. It's going to beat the negative 3. And this is a positive number. So my answer is going to be positive. I'll just keep it 7. All right. Let me show you this one on the number line so you can get an idea of what this looks like. Okay. So I'm going to go put my 0 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know I'm going to start with 10. Put some negatives over here in case I end up over there. Okay, so I'm starting at 0 because we always start with nothing here. And then I have positive 10, so I'm going to go positive 10. And now I'm going to add a negative 3, which means I'm going to go in a negative direction to the left. And I'm going to go 3 spots. I'm not going to go all the way to negative 3. That's a lot of distance. I'm only going to go 3 spaces to the left. So 1, 2, 3 right here. That's going to land me on 7, and my answer is 7. So this is a nice visual description. We're not just dealing with random numbers. Like, yeah, they're integers, they're digits, but they stand for something. They have a value. They can be shown on a number line with distance. They can be shown with like chips. I don't know if you did any of this, but if I have positive 10s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I have 3 negatives. A negative plus a positive makes a 0 pair. Positive 1 and negative 1, that just equals 0. So we can get rid of these, and we're left with 1, 2, 3, 4, 5, 6, 7. 7. And it's positive because there were 10 of these to start. There were 10 chips. So these really stand for something to help you understand why this works. But if you follow these rules, same signs, you add and keep the sign, or different signs, you subtract and you keep that sign of the bigger number, then you'll be awesome.